company does 150,000 tons of annual production, steel, very diverse in project scope. And this is the important one, and what I'll basically talk about today is that Supreme Group is more than a commodity-based business, a supply only. We see ourselves as a service provider. And with the service providing thought process, we feel that through the opportunities to collaborate, we're able to help influence our clients make decisions that are more towards the efficient options, and it allows us to offer a better product to them, more bang for a buck type mentality. So the title of the presentation is BIM Collaboration Strategies for Steel Fabricators, and I should say it's from a steel fabricator perspective. Talking earlier today, I know that we're in a project, or I'm involved with the project for a certain period of time, and then it goes on and it becomes something much greater. And as I was mentioning, sometimes we could have a successful project and it could go on to be something different. We hope not, but sometimes that happens. I know some of the people in the room are involved in some of the projects we've done, so hopefully that's not the case, but we'll go through it. This was the title that I originally had for this presentation. No I in BIM. It's a play on no I in team, obviously. There is an I in BIM. It's information, and to me this is the most important part. The way the steel industry goes about our business, some of you may know, is we have 3D modeling as part of our daily process. We traditionally take 2D drawings, build them into a 3D model, design connections. That's how we fit everything together. It's all about the information you're putting into the model because, as you'll see, we have a lot of direct uses for it, and it's critical that it's accurate. What I find we're in now is, as we look at BIM and we go through these integrated processes and the collaborative processes, that we're learning how to share the information. I think that's been touched on quite a bit. And these three graphics, I think they could probably mean a number of things. The first one could be, hey, I've got good information. It's in a model. Does anybody want it, or do you want something to do with it? Or it could be the opposite, saying, hey, I've got this great model and I don't know what to do with it. It could be a matter of, I've put a bunch of information together and it's not right and I don't know what to do about that. And basically the goal where we want to get is we're collaboratively assembling information, and we're actively involved, and we stay with it, and we make sure that it fits. And if it doesn't fit, we're working with the people who need to carry on forward with it to make sure that it becomes useful and accurate. So where are we at with this? This is focusing on the sharing of the information. This is a recent model I received, and the way our process works is we get bid packages essentially. Sometimes now they're containing a 3D model, and some people may know this. I've tried to blank out as much as I can because this is just supposed to be a general thing, but basically it says the 3D model is for information only, which is great. That's the whole intention of this, the intent of this process. However, neither the consultants or the contractor are responsible for the accuracy. Well, to me that's great. In terms of having the information. However, I don't know what I'm able to do with that information. This particular project is a large project. It's a very complex model. I'm sure a tremendous amount of effort went into that model, and it probably had some coordinational benefits for sure. But what it means to me is that if I'm going to use this model now, I have to use it very cautiously. And I can't be confident that if there's something not correct in the model, then is it going to be my responsibility for using it? Basically, my process is going to start back to the way it always has been. I'm going to go to the 2D section. I'm going to start building my own 3D model from this process. Tremendous duplication of effort will take place for sure. So we can talk about responsibility. I know this is probably a huge topic that I can't even start to get into on this thing, but if you look at an example from our world in the steel fabrication side of things, like I said, we do build models. There are models. They have our information put in by our people. The accuracy of that information is our responsibility. It's important to us, and maybe this is the biggest difference, is that you know, and I'll show that this model is Capital Theater, and it's a little bit different. Maybe I'll back up first. Sorry for jumping around. One of the models, the gray one, is one we built from the 2D drawing perspective, and the blue model is one that we inherited from an engineer of record, actually, and we basically just took it as a model and proceeded to work from it. That model was Capitol Theatre, and this is a project that many of you may have heard of. It's been talked about a lot as a BIM, successful BIM project. But we received the model, and then we started to do our process. And why we make sure that it's accurate is because we use the model to generate shop drawings. And I don't know if that's all that clear, sorry. But basically, this drawing is just a generated piece from the model, and much of the information that's shown on the drawing actually just gets fed through CNC machines. So basically, if one of those holes is wrong in the model, the piece will get made wrong, which inevitably just costs us money. So it's very important to us that our model is completely accurate, or it has, absolute impacts to us. We also use it for creating erection drawings for use in the field. And again, if something is wrong in the model, something will be wrong on this drawing. It will cause confusion in the field, and at the very least, the confusion will waste time. But if it's something more than that, then you could be looking at some significant impacts. With the Capitol Theatre project, and this is something that I've always been interested in, is we were able to share back our information in a useful way. I found from quite early on, well, 10, 12 years ago, say, starting in 3D modeling off of 2D drawings, you could find an issue and you could do like a screenshot or send it over to the engineer or the architect and say, hey, we've got a coordination issue, and they, wow, that's great. I appreciate seeing that detail. In this case, we were able to send it back in full level of detail and absolute accuracy. So we're seeing everything as we're working through it, as we're developing, and it becomes a collaborative process back and forth, saying, yeah, that works, no, that doesn't work, and then what do we do about it, and we can work through it together. To me, this was the truly collaborative scenario where we were not only sending information, but we were sharing it, and we were regularly putting it into the model. I'll go into this project a little bit more because I do have some specific project examples. But it was a successful process of applying the information, not just developing it and passing it along. So what made this particular project successful, and I know these are, early commitment is a hot topic because there's a cost to early commitment, but what do you get? You get valued expertise. And the way I think we managed the early commitment concern on that job was not necessarily to write a blank check to a supplier you want to work with, but basically we were told there's a budget to the project. We weren't told what it was, and we had to stay within it, and if we didn't, we were in jeopardy of losing the job, so or having it to go to tender or something like that. So we had to be cost-oriented right from the start, and what we asked in return is that we have the opportunity to influence some of the decisions to make it more cost-effective from our processes. So that was the trade-off, basically saying, okay, we have to work within a budget. You have to give us some control over what that budget's going to be, as opposed to just us trying to make what you want cheaper, because sometimes we can't do that. An open-minded approach, for sure, on this one. It was very different. Allow process to adjust to suit project requirements, not vice versa, and be actively involved. The way I got assigned to this project was that my boss came to me and he said, I've just gotten a new job. I don't know a whole lot about it, but basically we're not getting any drawings. We're getting a model, and it has a crazy timeline. There's a design meeting next week. Here's the contact information. I don't know a whole lot of companies that would be real eager to take on something like that, but we did it, and it was a great process, actually. It was a great stepping stone for us, and it helped us get familiar with this new process and start the motion forward. To get this early commitment, you obviously need to have trust, and this is called, I guess, the trust factor. I don't know. And we got invited to the Capitol Theatre project because there was other people involved that we had worked with prior, the engineer, the contractor, and I think they basically had the comfort to say, okay, we know this organization, and we trust that they'll be able to, to do all these things. They'll be able to perform, and they'll be mature, professional, and fair about it. And it's just ability and behavior, and it's something that builds. It's a team mindset, and once you have these relationships, you can really start to explore more and more benefits from them. This is a graph that I stole from another presentation that I had gotten access to, and the only reason I wanted it is because it shows points number 1 and 2 is basically where you can have the most benefit from involvement versus as the job goes on where you lose the opportunity to benefit from this input. So I hope that's not confusing, but it's kind of to say, you know, you need trust, you need to be able to get some input, and you need to be able to apply it as early on as possible to maximize the benefits that are potentially there. So I will look at, okay, no, we're ahead. 3 successful examples of collaboration strategies, which was sort of the intent of the presentation. These are 3 projects, and they do go back. The airport terminals started back in 2009. So I find with these kind of things, I do hands-on work. I'm very involved in projects, and I kind of resurface in between projects. So it'll be a year to a year and a half where I'll disappear into a project, and then I'll come back, and I come to some of these things, and I feel like it's been 10 years, the way the things develop. So I hope none of this is outdated, but maybe some of it is, but it'll be hopefully interesting. Capitol Theater, like I mentioned before, that was our first attempt at a BIM project. And the Marriott Hotel, Edmonton International Airport, the most recent project. I say it's an IPD. I think it's probably the closest example I can find or title I could find to the way that played out, but we'll get into that. So the Edmonton International Airport Air Terminal Building Expansion, that's the first one. This was a design assist project. The role I played on that job was basically the design assist coordinator, I guess. Mainly working with the design team and our own internal resources to get the information transferred. Definition of design assist. Design assist is a procurement method by which, prior to completion of a design, a construction contract may be awarded on a best value basis, pursuant to which a contractor provides design assist to the architect or engineer of record through design professional separately retained by the contractor. In this case, we have internal engineers as part of our design and drafting process, so that's what we offered there. What actually happened during the course of that project? Well, fast-paced development and processing of design information. I understand that the biggest driver for this project to go design assist was that they wanted to accelerate the schedule. And what that meant was, as the definition says, getting the work going prior to completion of the design stage. So what that means is the 2 processes basically become one, where you're building something as soon as it's designed. So that has a certain challenge, and one of the concerns with that is that quick decisions cannot easily be changed. And what that means is basically you make a decision, something is ready to go, and you're proceeding basically. And unless you quickly realize that we want to change something, there's going to be some impacts to that. I think, do I want to go here? Yeah, I want to back up. Maintain forward momentum. Again, like I said, you have to keep moving forward. We did get into situations where we were making decisions, moving forward with fabrication, and basically a change would come in, and even though that change might have been required, it was essentially too late for the process, in which case it was a known change that was going to be dealt with at another time where it would be the most efficient to do it. And if it was absolutely critical that the project stops, maybe backs up a little bit, we would do it, but that was sort of the, that was the last resort type thing. And this was, I think, probably a big one that maybe the design team, this was what I think would be probably the most new to them, the unconventional sequencing of design efforts. When we look at a project in terms of fabrication, basically it's hours, it's man hours, it's production time, it's shop hours. And what you have to make sure is that those number of hours, as anybody knows, there's only so many hours in a day. So you have to really be careful at managing those hours where you're using them up continually and you're not waiting and then you get kind of bombarded by all these hours needing to be done at once. An example of that is architecturally exposed structural steel trusses that are in several locations in the building. Well, 2 mainly, I guess. And this is one of them. And what we can't forget is that these things take a long time to build. So what we had to do there was, even though, like I say, these were spread out throughout the building, we had to focus the design efforts on, locking in what these trusses needed to look like, what they needed to do, get them designed so that we could start moving forward with fabrication. Because the other issue is, you see, it takes up a lot of space in the shop. And you can't have these things sitting in the shop for too long, or you can't have them put into the shop in the middle of doing smaller fabrication where you're just pounding the stuff through. So that was a little bit different, to focus basically the design sequencing efforts on what needed to be built first. An example of the quick information flow and where this, I feel, streamlined the process the most, and I think everybody on the project would agree, is that we would take rough hand sketch information from the engineer, and we would process that into our 3D model. Now, normally that would have been done by the engineer into 2D and then transferred to us, and we would have built this. We basically just took the information direct and sent it back. We didn't really have the translation software that's been talked about, so we just used the proprietary viewing software of the detailing, or the viewing option of the detailing software. And basically that became the way that we could do verification to say, is this right? Is this what you want? Do we need to make changes? It worked really quick. And then from there, it was already in our model. If it was a matter of yes, we were able to quickly advance into the shop drawing preparation process. What we achieved on the job, and these I guess are the highlights from how we saw it again as the steel fabricators. We were awarded the job in 2009, which I believe was at the 30% design development stage. And then we quickly moved to lock the structural design so that we could order the material, which was important because we had to hit the mill run dates. And we were able to actually do that and order 85% of the material, which turned out to be a significant savings compared to what could have happened if we were going to warehouses, or if we had missed some of these material prices at that time. We then started steel erection on site in 3 separate work fronts, 3 full crews, 3 cranes, in December 7, 2009, which is basically 5 months later. Now that is a tremendous amount of work. And the other thing with that, it doesn't mean we were just ready to start. It meant that we were able to continually feed these crews throughout the entire project. So we had to have a lot of work done in order to allow that to happen. And another interesting note in context is the IFC drawings were released 3 weeks after we started all this work on site. So we had really advanced the process, anybody who knows these typical timelines can see. In the end, we ended up with 3,400 tons of mostly architecturally exposed structural steel supplied and erected by July 2010, which was basically 13 months. And I've never seen the original schedule, but from what I've heard at other presentations on this project, the structure, I believe we hit a milestone which was a year ahead of the original schedule that was based on conventional methods. There's people in that room that can verify that. If it's not, I'll apologize. A little bit of information on the way it was contracted. I know this is probably interesting to some people, because the contract issue is probably the biggest roadblock that we're finding with this open process. We were contracted to a construction manager, supplier, and erector for steel and metal deck, which included a design assist commitment for a stipulated amount of time. That ended up extending through the duration of the project because there was just simply no other way to do it. It was released as a tender package based on a typical bay framing schematic through competitive bid. We were awarded the project, and we had defined our scope through what we call the bid model, which was basically our assessment of what was required and what we were looking to offer, as part of our offer. And the way to work through that then is to constantly monitor and communicate design changes to scope. This project had a lot of changes, a lot of adjustment, and we worked through those with just continued communication. The next one was BIM, and I'm going to try and speed up a bit because I think I'm taking a little longer. Capitol Theater. So this is a wordy definition, and I just pulled all these definitions quickly off the internet. BIM is a process involving generation and management of digital representations of physical and functional characteristics of a facility. The resulting building information models become shared knowledge resources and support decision-making abilities for these conceptual stages through design, construction, operational life, and eventually demolition. Now, that's a mouthful. To me, it's information that is built into a model, like what was talked about earlier. What happened on this project is that we strategically shared resources among disciplines, and this is probably the biggest benefit, where we worked with the engineer of record to say, where do you need to take the model in terms for it to become enough that we can start work, and we'll take it from there, and together we'll continue. So I think what we did there successfully was we significantly reduced the work duplication that normally takes place. We had near real-time sharing of developing information. People working live within the central Revit file, which is how the project was done. Would upload basically every 30 minutes. The detailing that we do is done in separate software, so we just came up with a timeline. I think we did it once a week or more frequently as needed if we wanted to bring that information back. Live clash detection in the model, concise decision making again, and maintain forward progress. We achieved a paperless process with 0 RFIs. We had major design changes with minimal impact, and a quick touch on that is midway through our process, it was determined that moment forces were to be factored into the design. And you see the picture on the left is HSS column, which was originally what the framing was called up to be. In order to accommodate those loads, we would have had to either cut the columns and put plates straight through, which was quite expensive on production. We came up with the idea to wrap around, which then led to clashes in other systems. So we looked at a third option of changing them all to wide flange columns. And because we were so early in the process, it wasn't really a big deal to make a change, completely change all your column framing members at that time, because we were still in the thinking process. So we were able to do that with little to no impact. We did strategic scope addition, where we were well into our process and went into the central model where things just appear, and we had all these, it's hard to see, but there's a bunch of little infill beams that were added there, and start communicating and say, hey, well, what's going on with these beams? They were added in to support a catwalk frame, and they were going to be all secondary work. We looked at the costs of doing those as field work, and it was extremely difficult because the building would have been decked by that time, and this was over top of an audience chamber in a theater, which had a kind of a stepped floor. We would have to do false work platforms to get up, or false working platforms. So we basically looked at the cost of that and then priced out just applying it to our original scope, doing some changes, some rework in the shop, and doing it all as first pass erecting work. And it was about 50% of the cost. So that became a decision that the team made, added into the scope. And even though it was an add, it was a significant savings. Here's to back up quick. That was successful scope adjustments. And the project on the structural side had about a 3 to 4 month schedule gain compared to conventional schedule. And this was a small job. So if you factor that out, you can see how there could have been tremendous benefits on a large project. Quickly on the contract side, we contracted to a general contractor as a supplier and erector of structural steel and deck. Again, and basically it was a design assist commitment through the modeling process. We were selected through a non-competitive bid, but we had to fall within the budget, like I said before. That was a trust thing, and in this case, the engineer of record established the baseline for scope definition. Essentially, a bid model that was posted in the central Revit file at a certain date, certain time. Basically, that represented what our budget was based on, and we took it from there. Constantly monitor, communicate design changes, and considering how early we started on this project and the fact that we did have some major changes and some scope adds, there was an 8% cost increase to the owner by the end of the project from our part, and I think that's I don't know, pretty reasonable in terms of not having a competitive bid process and working within a budget. The last one, and this is loosely an IPD, and I'll try and get through it quick, probably about, how much, 5? Okay, 5 minutes. The Marriott Hotel, I'll call it an IPD. I guess that's maybe not, but IPD is a collaborative alliance of people, systems, business structures, and practices into a process that harnesses the talents and insights of all participants to optimize project results, increase value to the owner, reduce waste, maximize efficiency through all phases of design, fabrication, and construction. This is the perfect scenario type thing, and if we had have had more 3D capable I guess, team members on this project, it would have been a great BIM project. It wasn't really, we sort of made it an internal BIM within our organization and tried to share as much as we could with the rest of the team. What actually happened, on this case, because it was so open, we were actually able to offer a design option for a construction method that we felt worked for the owner's benefit and accommodated some project challenges that they were having. That was a girder slab method, and I won't get into that, but it's basically sort of a hybrid steel design with precast concrete and it's very low floor-to-floor height, which is what was essential for this project. We produced our own design model. We did a structural design using RAM, and then we took that design and we gave the owners a budget, and basically the budget worked, the design worked, and we worked collaboratively with the engineer of record and the architect, basically ensuring that our design that we were doing met the requirements, and also under the understanding that the engineer of record was going to inherit our design and basically make it theirs, and they were going to be the engineer of record to our design. So very close working relationship there, and it worked out really, really well. What we achieved, the girder slab method, as I said, we had a budget-based agreement on scope and price. So again, to us, this was non-competitive. It was very direct in terms of a timeline, and it achieved what the owners were looking for. And we were able to accelerate the schedule because we had done the design through our internal processes, and we were very comfortable, obviously, in sharing the model. And so the design model became the detailing model, and we didn't have to recreate anything. Again, if there was a mistake, it's easy to say whose it was. So we didn't have those concerns, so we could very freely pass the information sort of upstream and downstream within us, and share all that with the engineer of record to make sure everything was acceptable and sufficient. Here's a photo of girder slabs, so just quick. Fabricated D-beams nesting a hollow core within them, and then we grout that all in, and basically the steel frame disappears within the floor. The other benefit to the owner, in this case the owner wanted to be a self-performing GC. They liked the one-stop shop idea, didn't want to have to do too much cross-trade coordination, so this method also allowed that benefit. So like I said, we contracted direct to the owner as a supplier and installer for structural steel metal deck and the full girder slab system through non-competitive process. Again, we had an established baseline to define scope, constantly monitor changes, and at the end of this project, we had a less than 5% cost increase to the owner based on the original contract value, and there were some scope additions in there as the design went on. So to me, again, early commitment, doesn't always necessarily mean you're going to be in trouble money-wise. I think this is another good example of how that can work. So a short summary. BIM has given people a reason to entertain the possibility of change to a system that is long overdue for major adjustment. I think that's fair to say. I don't think it's really been, well, it hasn't been established yet, but I think it's got everybody thinking about change, which is great. Be open to this opportunity for change because it's truly an opportunity, and be creative when considering options as to how to best execute your projects. Thank you.